Hello everyone, welcome back to my channel. In today's video, I'm going to show you how to build an amazing hand gesture controlled vehicle using the MPU6050 gyroscope module and the ESP-NOW protocol. This project allows you to control a car simply by moving your hand in different directions. No physical controller required. If you're new here, don't forget to subscribe to the channel and turn on the notification bell so you never miss any of my upcoming videos. For this project, we will need 4 gear motors, 4 wheels, and a PVC board to use as the chassis. We also need 2 small breadboards, 2 battery packs, one for the transmitter and one for the receiver, an MPU6050 gyroscope sensor, 2 ESP32 boards, one will act as the transmitter and the other as the receiver, an L298N motor driver, and a 6-terminal jumper wire set. Let me first summarize the transmitter components and then the receiver component. Now let's understand how this system actually works. The MPU6050 sensor detects the movement of your hand in different directions. For each movement, it generates different X and Y axis values and sends those values to the ESP32 microcontroller. Based on the X and Y data, the microcontroller determines the direction in which the hand is tilted. After that, it transmits the corresponding data wirelessly to the receiver ESP32 using the ESP-NOW protocol. ESP-NOW enables 2 ESP devices to communicate directly with each other using their built-in Wi-Fi radios in peer-to-peer mode. The devices pair by exchanging their MAC addresses, and once paired, they can send small packets of data without needing to connect to any Wi-Fi router. Now, let's move on to building the receiver side. First, I have attached all 4 motors securely to the chassis. Then, I connected the positive terminals of both left side motors together and the negative terminals of both left side motors together. I did the same for the 2 motors on the right side. Make sure that both motors on the same side rotate in the same direction, otherwise the car will not move properly. Next, I took the L298N motor driver and a 2-cell battery. I connected the positive terminal of the battery to the plus 12 volts terminal of the L298N motor driver and the negative terminal of the battery to the ground terminal of the motor driver. Then, I connected a jumper wire from the 5-volt output terminal of the L298N motor driver to use it as a 5-volt supply for powering the ESP32. Once confirmed, I mounted the motor driver and the battery securely onto the chassis. Then, I connected the left and right motor terminals to the motor output pins of the L298N driver. On a breadboard, I placed the ESP32 and mounted it on the chassis. I connected the 5 volts output supply to the VIN pin of the ESP32 and connected the ground properly. Make sure that both the motor driver and the ESP32 are powered correctly before proceeding. Next, I used a 6-terminal jumper wire to connect the signal pins of the motor driver to the GPIO pins of the ESP32, following the connection table shown on the screen. After completing all the connections, I connected the receiver ESP32 to my computer using a USB cable. Then, I unzipped the code file provided in the video description. To calibrate the motor direction, I first opened the motor test code and uploaded it to the receiver ESP32. This test code runs all the motors in the forward direction. If any motor rotates backward instead of forward, observe carefully which motor is running in reverse. Then simply interchange the 2 terminals of that motor. After correcting the wiring, make sure all motors run forward properly. Once everything is working correctly, we can move to the next step. Now open the main receiver code. Select the ESP32 dev module as the board, choose the correct COM port, and upload the code to the receiver ESP32. After uploading, you will see the ESP32 board details in the serial monitor. From there, you will get the MAC address of the receiver ESP32. Alternatively, you can upload a simple MAC address code to the ESP32, and the MAC address will be displayed in the serial monitor. We need to copy and save this MAC address because it must be entered into the transmitter code. Now let's build the transmitter. On a breadboard, I placed another ESP32 along with the MPU6050 sensor. Here you can see the connection between the ESP32 and the MPU6050 module. To power both the ESP32 and the MPU6050 sensor, I connected a 3.7 volts lithium-ion battery. It is very important to place the MPU6050 sensor perpendicular to the breadboard, exactly as shown. If it is not positioned properly, it may generate incorrect or unstable readings. I connected the positive terminal of the battery to the VIN pin of the ESP32 and the negative terminal to the ground pin of the ESP32. Now, open the transmitter code. In this code, we need to insert the MAC address of the receiver ESP32 that we obtained earlier while uploading the receiver program. Locate the section in the code where the MAC address is defined, and carefully enter the receiver's MAC address in the same format as shown on the screen. Once that is done, select ESP32 dev module as the board, choose the correct COM port, and upload the code to the transmitter ESP32. After uploading, open the serial monitor for both the transmitter and the receiver. In the transmitter's serial monitor, you should see a Send Success message, which confirms that the data is being transmitted properly. Now it's time to test the car. As you can see, the vehicle responds smoothly and accurately to hand gestures, moving perfectly according to the tilt of the hand. Thank you so much for watching the full video.